it the explosion, but it could be, it is not always a very clear explosion. So it could be someone standing, they like these examples. So you've got a person, and the person is standing on ice or on a skateboard or something that can move. And then the person throws a ball or something this way. So you can think about it. If you're going to throw a ball that way, it's going to push you to go this way. So that means in the beginning, the person and the ball was stationary, and so they're standing still. So they have no momentum. So for those questions, what you need to remember is that P initial, the initial momentum, is always going to be zero. Because also, even if it was a bomb exploding, nothing happens before it explodes. That's why I call it an explosion, because it's quiet before the storm, basically. So the initial velocity is always going to be zero. Then the next scenario, we'll look at the examples now. Oh, they're not. Yeah, it's not really a collision, but it's two things moving away from each other. So that's why I rather call it an explosion, because there's still some change of motion, and there's still two objects involved, and that ball couldn't have moved if you didn't throw it. So the two objects still has an F net acting on them. And if they still have an F net acting on them and they end up moving in different directions, or even in the same direction at different speeds, then it is still kind of a collision in inverted commas. But that's why I rather call it an explosion. We'll look at it. If this is one of them, like it's a momentum question. There's going to be two objects always. So when you see two objects, chances are that it's going to be momentum. It's going to be a collision. As soon as there's two objects, because in kinematics it's only one object at a time that's moving. In energy, it's only one object at a time that's moving. So when you see two objects involved and they end up moving differently, so there's a change in their velocity, then you know you're going to use momentum. You'll also see the more you practice, the more, and also it's question 5. That's terrible to say. But when we start looking at past exam papers, you're going to see, and I'm hoping that we get to there, that when you look at the exam paper, you're going to be so familiar with the way the questions arrive. So normally it's vectors in the first question, and then it moves over to kinematics, and then it moves over to momentum, and then it moves over to energy, and then it moves over, or yeah, it's kind of, yeah, but with momentum, yeah, it could be forces as well. So forces in Newton. So although these are all mechanics, it does follow on one another, and the more past papers you'll do, the more familiar you'll become with what are they actually asking me. And the other thing is, you just put, when you read your question, like we just did earlier when we were doing these things, when you read your question and you put this in and you say, okay, they're giving me an F net, they're giving me a time, they're giving me a mass, and then you go to your information sheet and you go and find those things on your information sheet, it's always going to lead you to the right section. Your information sheet is your second best friend after your calculator in the exam, because it will, if you have no clue where to start, just do what we did there and it will lead you to the right equation always. A lot of exam tricks that you'll see that we can do. The other scenario, so this is the one where they're both standing together. Then there is another scenario where you can have two objects coming towards each other and they can stop. So you have one coming this way and one coming this way, and then they just stop here in the middle. So that will be momentum final is equal to 0. They don't ask that often. They like the ones where they're both moving. So you will have one car coming in one direction. So this car will be coming this way, and you'll have another car coming in this direction. So that will be your A, and you'll be, like we said earlier. And then there can be different things happening. They can both end up going this way. So they can be touching each other and now traveling together as one object. And then you can say A plus B. Their mass becomes A plus B. And they have one combined final velocity. So it's A, B velocity together. Or they can both end up moving. So after the collision, A can be now moving this way and B can be moving this way. So you just read your question nicely, and 90% of the time there is a diagram. So just go and fill in, or like you can see here, you could, this one I'm not going to do because you can go through it, it is there. We can rather do one that's not done in the notes. But once you get your diagram, fill in everything. And if there is no diagram, draw one, because they will give you marks if they can figure out what is going on in your diagram. So let's just do one quickly that we can see how this works. We could do the rifle 1 second because that's one of those explosion ones. So let's just do this one first. So this one doesn't have a diagram now. So they say a railway truck is moving at a constant speed of 5 meters per second. Also, in a momentum question, there will never be friction. Okay, so it's because we look at that moment when they collide. There's never going to be, and momentum can only be used when the system is an isolated system. So there can't be friction. So that's another way of knowing that it is going to be momentum. But let's see. They're giving us a mass here. There's a railway truck. And so we'll just call it RT, mass of the railway truck. It's moving at a speed of 5 meters per second. So we have a V or a U. Then they say collides with a stationary truck. So we know U here is 0. So we'll just call this, that is railway truck, and this is just truck. Stationary truck with a mass of that. So that's the mass of the truck. If the two trucks couple during the collision, so what they just mean they're moving together during the collision, they become one basically during the collision, what is their combined speed? So they're asking us for the final speed, and because it's combined, we can say it's RT plus truck. So you can see there's two objects. There's a collision, but this one was clear that it is a collision. If you see the word collision, then obviously that helps a lot. So now you know you're going to use momentum. And whenever there's two objects, it's going to be conservation of momentum. If there's just one object, it could be impulse. But if there's two objects, you're going to always use conservation of momentum. So you're going to say momentum initial is equal to momentum final. But it's the sum of all the momentums before is equal to the sum of all the momentums after. If you don't have to write that step. You can just say mu plus mu. So this is the railway truck and u of the railway truck, plus mass of the truck, u of the truck, is then going to be equal, and I'm just going to write it out for now, mv plus mv. And this is again railway truck, and this is truck. There's a lot of writing for this, but you must be, it's okay, you'll see it. It works out because now here, you know they are going to join. They say they couple together. So what you can do when they couple together, you can skip that step and you can say, okay, their masses are going to be their combined masses. So it's going to be the mass of the railway truck plus the truck. That's going to be my mass. And they move together, so they're going to have one speed. So it takes one unknown out of your equation. So you can go straight into that. The other thing, as soon as you see that it's stationary, you can immediately go to that object and make it 0. Because if u is 0, mu is going to be 0. So this part of my equation immediately becomes 0. And then here we've got the math. That part stays the same. So you could have immediately written down the equation like this. But there's no rule that you can't start with where the law comes from, because that first bit, this is the law of conservation, that total momentum in an isolated system remains constant. Now we can put our values in. So we know the mass of the railway track is 3,000. It's moving at a speed of 5 plus 0. Now we can add their masses together is 7,000 and V, and the math becomes easy. So you just go and work out your V. Is that easy? Okay. Now for the explosion one, at the top there, you're still going to have two objects. They say a bullet of mass, so they're giving us a mass. Again, we're going to change it into 0.15 kilograms, is fired from a rifle. The bullet's velocity as it leaves the rifle is 300 meters per second. So this is actually V for the bullet, because it's as it leaves the rifle. And the mass of the rifle is 5 kilograms. So yeah, let's call it bullet rifle. Calculate the recoil velocity of the rifle. So in the exam, they're not allowed to use words that the whole country will not understand. So they can't really use recoil velocity if they don't explain what it is. So in a question like this, you'll definitely have a diagram. So what it is you've got your rifle, you've got your bullet. And then the bullet goes out of the rifle and the rifle goes back. So this is the recoil velocity of the rifle that they're asking you for. They've given you V for the bullet. So this is after the collision. So where does the collision happen actually? Inside. So that is why this is that type of explosion question. So initially, the rifle and the bullet is just standing still. So this is where you're going to say momentum initial is still equal to momentum final, but momentum initial is 0 because they're not moving. And then momentum final is going to be M of the rifle, V of the rifle, plus M of the bullet, V of the bullet. But now very important, you need to go and assign a direction, because there's two different directions that you have to decide. So let's just say, let to the right be positive. So if to the right is positive, then that means that V of the bullet is going to be positive. And don't put a negative to something that you haven't worked out yet. Okay, so don't go and make that negative. The question will make it negative for you. The answer will become negative, you'll see. It will confirm your direction. So now let's see. We're going to put in mass of the rifle is 5. V of the rifle is what they are asking us for. That's a 0. Plus the mass of the bullet is 0.15. The velocity of the bullet we decided is positive, 300. And now you must just make sure that the algebra works out correctly, because now you're going to see that 5 VR is equal to minus 0.15 times by 300. And then you can divide by your 5, and this will give you a negative answer. And you see that. If you type, it's going to give you a negative answer. So you get your negative answer. But remember, then you always go back to the question and see, okay, what did they actually ask me? They asked for recoil velocity. And you're going to say, therefore, V recoil is equal to, and you give your answer as a positive, whatever that was, I don't know exactly, you can work it out on your calculator. Whatever, I can guess I can. 0.3 is 990? No, can't be. Should be pretty small. What do we get? Okay, 9 is better. Because, yeah, so you must also look at if it's realistic. 90 is a bit fast for a bullet. If that rifle comes back at 90 meters per second, it will hurt you badly. Okay, so this is 9 meters per second, minus 9, and then you're going to say recoil velocity is 9 meters per second, and then you put the direction. So what would you put as a direction here? Left, because you've got a diagram. As soon as you have drawn a diagram, you can state the direction according to your diagram that you have drawn. And that's momentum, that's conservation of momentum. The only one we haven't done, let's see if there is one quickly, if you have time, for one that moves in different directions. I'm just going to check if there is one here. Do you have a bit of time? Can we do one more? Okay, just so that we can get this type of example as well. So this one here, 6.3, they're telling us that a tennis ball of mass that rolls at 3 meters per second towards a cricket ball of that mass at 1 meter per second, and they collide head on. So if they collide head on, it means they're going in opposite directions. So we've got our tennis ball, and let's just say it's rolling this way. And then we've got the cricket ball, and it's rolling this way. So this here is 3 meters per second, and this is 1 meter per second. So now, if we do that, if it has a value, you have to assign a sign to it. If it's a V, if it's an unknown, you don't. So now it has a value, so we need to decide. What do you want to be positive? Yeah, it's just everyone always decides. So that's just easier. You don't get confused. So if we say to the right is positive, then this will be positive. No. The 3 will be positive and the 1 will be negative. So you're just going to write that somewhere on your paper. Let to the right be positive. Even if you just do the arrow, it's absolutely fine. Now we're going to say they want the velocity of the cricket ball after the collision. They tell you that the tennis ball bounces back and moves off at a velocity of 2. So now we know that after the collision, just put it in here. After the collision, the tennis ball is going to go this way at 2 meters per second. But once you write it, immediately put the minus. So now we're going to do the same thing. We're going to say M tennis ball, U tennis ball, plus M cricket ball, U cricket ball, equals. So that's the initial. So you don't have to, so that's momentum initial, the two different things. Then we're going to do momentum final. So that's M tennis ball, V tennis ball, plus M cricket ball, V cricket ball. So momentum after. And then we put our values in, but here is where you must be very careful with the signs. So the tennis ball is 200 grams, so that's 0.2. Oops. Not 0.0, 0.2. And it rolled at 3 meters. And we have it in our diagram so we can see it clearly. Plus, the cricket ball is 0.5 times by, this is then going to be minus 1. So now you can see, because of the pluses and minuses, it's not just going to be a fraction out or a power of 10 out. If you put the minus, your answer won't be the same and just a negative sign. Your answer is going to be totally wrong if you forget a minus. The mass of the tennis ball is still 0.2, and they told us that it rebounds at minus 2, plus the 0.5 and velocity of the cricket ball is what we want. And then the rest becomes algebra. So now your calculator's job. So now you just must make sure that you do the sign correctly on your calculator. And I want you to quickly work it out for us that we see what sign we have. Because they didn't tell us which way the cricket ball is moving. The cricket ball might end up moving this way still, or it might end up going that way. That's why you're not allowed to put a sign in. The answer is going to tell you the direction. I'm just doing one head maths. Yeah, 0.5, yeah. I was, because you're dividing, you're minusing, you're plusing, and then you're positive 1. So the answer is +1, yeah, meters per second. But now again, you can't leave it like that. You have to go back and say, what did they ask me? So you're going to say, therefore, because if it's positive, you can just go and write to the right. But I always think we neglect the positive and we give so much attention to the negative. Because the positive still has meaning. Because it's positive, it means that the cricket ball ends up moving to the right. If that answer was negative, then you would say, therefore, moving to the left. So don't make up a direction. The question will tell you